Okay, for the next step, we're going to create a new field in an attribute table. So I'm going to open up the attribute table for the Spokane watersheds. And so far, anytime we've been dealing with data, we've really just dealt with the attributes or the columns that were provided to us in that data set. So now we want to actually kind of create a new attribute. So we'll go back up to this table options icon up here in the upper left. This is where we did our select by attributes, where we ran that query to get to just the watersheds near Spokane. And now I want to go a little bit further down and hit add field. So I'm going to add, instead of, what we're going to do here is instead of dealing with our 8-digit hydrologic unit code, we want to create a 6-digit where we only keep the first 6 numbers. So I'm going to call it HUC6. It's going to be a long integer as its data type, and I'll keep the other default values there. So you'll see that it created that. Now, in most cases when you are editing tables, so I could go in here and I could see maybe there was just an error in my data, that it said something about, Pennsylvania or something, that there was something. I could go and I could put this table into an edit mode and I could go in there and overwrite. In most cases, you want to be careful about editing tables because you're going to assume that the data provider sort of knew what they were doing. So we're going to get an error when I'm over here. So it's not an error, but it's more of a warning. So if I right-click on this, I'm going to bring up the field calculator. So the field calculator is a way of overriding these null values with some new value. So, but it comes up with this warning. It says you're about to do this outside of an edit session. So the advantage of being in an edit session is I could be making changes, and I could be doing calculations. I could be converting maybe square miles to or square kilometers to square miles, or something. And an edit session lets you maybe create a new table or overwrite, and there's a lot of ability to undo. When you use a field calculator, you have no ability to undo, and that's what this warning message is telling us. But we're creating a new field, and if I don't like the results, I can just actually delete the whole column. So we'll go ahead and hit yes. Now, I think it's been mentioned in class and probably in other labs that a lot of what ArcGIS is doing in the background is running code, and most of that code is written in the Python computer language. But this field calculator has the ability to run using Visual Basic syntax and also Python syntax. So we're going to go and use a Python command. So the first thing I want to do is use a command called int, which is just going to convert a string to a number. Anyway, this isn't a programming class. We're not going to really talk too much about some of the codes over there. But anyway, I need this because I can tell, because of the justification that my HUC8, like we talked about earlier, is a string. So I need this new, so it's saying this new 6-digit code is going to be based on the 8-digit code. And if I divide by 100, it's going to essentially truncate off those last 2 digits, because if you remember when we defined this as a long integer, so it's going to force the output to also be an integer, and so by dividing by 100 it essentially gets rid of those last 2. So I'm going to hit OK, and it's calculating, and you'll see that it populated this table field up here, and I can verify that it did indeed do the right thing, that it's, I can see this 170102s and then 03s. So I'm left with 2 different numbers. So I'm going to do a little bit with symbology so we can kind of visualize where these 2 different basins are based on the 6-digit code. So if I go back over to the watersheds, under properties, I can work on my symbology. So instead of it being colored as a single field, I want to color it where I have a unique value or a unique color for every unique value based on that HUC6 code. I'm going to add all values, and so it's going to create 2 different colors for all available values within that field. So I can hit apply, and you'll see that I have these two basins. One of them is kind of more around Priest Lake and Lake Pend Oreille, and this one is more, from the Coeur d'Alene Lake through the Spokane, and it also includes that Hangman Valley. So the next part of the lab, we want to use what's called the dissolve tool. So with these Spokane watersheds, we actually still have 8 different polygons. So we have 3 in this and 5 in this lower basin. And the dissolve tool will actually create larger basins. So we'll dissolve these 3 into one and these 5 into a second one. So we could go up to Arc Toolbox, and if we remembered exactly where the dissolve tool, which sub-toolbox it was, we could navigate to it like we did in the previous lab. But sometimes all we really remember was it's called something like dissolve. So over here in this geoprocessing tool, so last lab we used the geoprocessing clip, and we're going to use this intersect and buffer a little bit later. But down here sometimes it's easier just if we remember the name of the tool to use this search for tools. Yours might be docked when we put this up over here. Sometimes it floats around freely. But if I type in the name dissolve, I'll see that I get kind of 4 different sort of tools that come up. But I'm going to go ahead and hit enter. And I'll actually see all the times that dissolve, sort of that term dissolve, comes up in any of the different tools. And I could go over here, I could expand it, or I could click on any of these and get more details about what it is I want to do. In this case, we're going to use the dissolve data management tool. So like all tools in Arc Toolbox, they're formatted pretty similarly. I always think it's helpful to remember to keep the help unhidden so that I can remember. But you can see from this graphic what it's going to do. It's going to take these and merge it into one. It's going to take these 2 and merge it into another, and these 3 and merge it into there. So the input feature, I've been getting this error a lot. I actually think it has something to do with how we're running things in Apps Anywhere. But anyway, if you get that, just hit yes, and I don't know, sometimes depending on what you're doing, it can come up a lot. It seems to be anytime we want to hit that browser button to find what we're doing. Okay, but my input is Spokane watersheds. I want to make sure I'm putting it somewhere appropriate. I actually want to make sure it goes into my new geodatabase under base data, and I'm going to call it basins. So yeah, under base data, you'll see that the data, the watersheds that we created is already there, but I'm going to say yes. And then it's saying, what do I want to dissolve by? So what is the attribute that's going to tell me that particular entities are the same? And so in this case, it's that newly created 6-digit hydrologic unit code. So I'm going to go ahead and hit OK. Whenever we're running tools, see down here in the bottom in this lower left, you'll actually see that it's running that tool. Sometimes it's hard to get confirmation, and certain tools can take 10 minutes to run or nothing. But anyway, we get that blue text scrolling, and then this pop-up box will come saying that it successfully ran the tool. So I can see now that it's created just 2 different units. If I open the attribute table, all that I get is that I have 2 different shapes, and then I have that attribute, right, of the hydrologic unit code, the 6 digits. So I'm going to get rid of this search for tools, and just to remind you, so under geoprocessing, search for tools. It can be a lot easier than trying to navigate through all those little sub-toolboxes of our toolbox. But next I want to start working with add an additional data feature. So far everything that we've been doing in this lab has been polygon data, right? So it's things that have an area. I want to go back to the Z class Washington, and I want to add some stream data, stream and river data. So if I navigate over to Washington, NHD major, so there's a folder and a geodatabase where I have water features. So I can I have different major water bodies, this is a different watershed set, but I want to add this line data that's for major streams. So I'm going to go ahead and add it. It doesn't give me that warning because remember we've already defined the transformation. So if it didn't know, it will do, depending on whatever coordinate system, it will automatically transform it over to ours. And we can sort of zoom out and you can see that it is a major streams. I want to go over here. We can open the attribute table. We can see some information about it. It also has reach codes, and if this might start looking familiar, so the reach codes are related to the hydrologic unit codes, right? So if it's in that particular basin, you'll see some numbers that are similar to it. It also kind of defines what type, whether it's been a modified what they call artificial path, where there's been something modified. We have a lot of that in Washington because of the dams. So it's not that we have a ton of canals, it's just that we have a lot of modified stream paths because of our hydrologic dams. And the column that we're going to use a lot is this stream order. And so I'm not sure if you've talked about stream orders in your hydrologic science class, but as the number gets larger, the river or water body gets more major. So as you move, a small like ephemeral stream or creek might be a 1 or a 2, and then like these large ones could be, more like as I say, like the Columbia, like major rivers. So I can sort descending, and you can see that they go from 10 down to essentially either not known or 0, which if I look at it as the zeros are these canals or irrigation ones. So I'm going to go ahead and close that. I don't want to have all these different types based on whether it's a canal or not. I want to go ahead and change my symbology back to a single feature, and I'm going to go ahead and use this kind of predefined river value. So you can see as I zoom out, it's for all streams that have some portion in Washington State. Okay, so since our watersheds are only in the northeast part of the state, I want to limit the number of rivers and streams I see to that northeast part of the state. So as I showed you just a second ago in the attribute table, that there's a reach code that's related to the hydrologic unit code. So I am going to create a definition query like we did last lab. So instead of exporting and limiting the data, I'm just going to limit what we see and can work with. So I'm going to use a definition query, and I want my reach code to be like, similar to what we did before. I remember that it's in text, so 17010, and then my wildcard. So reminding you that this is going to look for, it's not things similar to, but it actually has to be an exact match of a text string that has 17010, and then it can have anything after it because of this wildcard. But I also don't, so it's going to limit, if I went ahead and hit OK, you can see that it limits it to those. But I also want to only look at larger rivers. So I'm going to go ahead and do an AND, so both, not an OR, but an AND. So the reach code has to meet this, but this is going to further limit it, and I'm going to say that my stream order needs to be greater than 5. So it's going to take any streams and rivers that have 6, 7, 8, 9, or 10. So if I hit that out and hit apply, you can see that it got rid of a lot of the streams. I want to go back to my labels. Go ahead and it's going to have it defined as name, and I'm going to go ahead and hit OK. If I bring up the attribute table for this streams now, even though it's been limited just to the northeast corner and those two watersheds we're dealing with, you'll see that there's still over 1,800 records. So looking at just the Spokane River alone, there's lots of different subsections within each stream, so it doesn't treat it as a single river, and you can kind of, by sorting through it and scrolling through, you can see each one of these. The Spokane River is actually lots and lots of different reach codes. So the next step that I want to do is to create a buffer. I want to use the buffer tool. So maybe I'm interested in how much of the watershed is within maybe a certain distance of a stream order 6 or above. So if I go to the geoprocessing tool, I'll see this buffer tool. And buffers are a pretty common tool to use in GIS, just because a lot of times we want to know whether things are within a certain distance of a school or whatnot. But this buffer tool, like I said, I always like to keep that help open. What do we want to buffer? Super annoying. Oh, come back here, mouse. I want to buffer my streams. You can buffer polygons, you can buffer points, you can buffer lines. So I want it to go back to, make sure I'm in the right one, watershed base data. I'm going to call it river buffer. And then how far do I want to buffer? I want to know what is within 1 mile of any stream. And as if I go through each one of these, it'll give me some additional information about any of these optional ones. What I do want to do is dissolve. So I don't want to have, we saw how there's 1,800 segments within there. I don't want it to create 1,800 buffers. I want it to go ahead and dissolve, and I'm going to go ahead and dissolve all. I could dissolve by some other field, but so for each one, it's going to create a single buffer for all the features, and I'll kind of show you what this looks like. So go ahead and hit OK. It's going to be running that buffer down in the bottom, and we'll get the pop-up box, and it will add the feature when it's done running. So we see that it's done, and we see this river buffer. And if I go ahead and open that attribute table, you'll see that it created a single buffer. So it took all those 1,800 pieces of the various streams, and it created, even though you'll notice that these two are not connected, they're in different watersheds. So that's kind of an interesting way of doing it, where it creates a single, I was going to see if I could click it, but I have other layers that it wants to grab, but it's calling this a single polygon, even though I have little subsections all the way through. So I have, because I didn't clip back my streams at the county lines, my buffers now also sort of go into Idaho and British Columbia. I'm going to go ahead and use the clip tool that we used in the last lab to limit these back to Washington counties. So what is it that I want to click? I want to clip back my river buffers. I want to clip it back to my counties, and I'm going to hit OK and run through. You can see it running down here in the lower left. Right? And now I have a river buffer clip and a river buffer. I'm going to go ahead and remove that other one because all I care about is the clipped. I'm worried about my names getting a little long, so I might go ahead and change this. So I have my river buffers that are clipped. You can see I get a little piece of it there and there. I can turn off my basins, see them a little bit better. So the next thing I want to do is start applying one more tool, because maybe the question that I'm trying to answer is how much land in any county is within 1 mile of a stream order 6 or above. So we're going to use what's called an intercept tool for that. So the intersect tool is up here in geoprocessing again, and intersect. And we'll be able to see over here in the help feature what it's going to do. So this is a pretty powerful tool within GIS. And so what it's going to say is if I have the input, and so in my case my input is going to be the counties, and then my intersect feature is going to be the buffers. And so maybe I have part of the buffer that was outside of my counties. This would have been if I hadn't clipped it, right? So this could have been area in Idaho or British Columbia. But it's also then going to take this single feature and it's going to divide it out according to how it falls within this underlaying layer. So if I have part of it in one county, it's going to create a subsection there, and if I have part of it in another county. So it's going to take on the attributes essentially of the layer below it, and also take on the boundaries of it. And so this is a pretty fast way if we wanted to subdivide this single entity of buffer into some sort of geographic unit. Oh my gosh, this thing. So the input features that I'm worried about, so I need both my bottom layer and my intersect layer. So I need it to say my river buffer and my counties. So I want it to output to, I'm going to call it buffer county, or buffer CO maybe, to keep my layer names relatively small. So buffer by county, and I'm going to leave the defaults here, but as always I can go and read more about these default values to make sure they're what I want. So I'm going to hit OK. It's running through the tool down here. And it's put a new one. So just to remind you, when we had the river buffer, I had a single entity even though it was discontinuous. When I look at the buffer by county, I'm going to have, looks like I'm going to be in at least 4 different counties. But actually if I look way down in here, I see I have a little bit in that county as well. And so I get 6 counties. So it has all the features, right, of what before, right? So it has, these are all my county features are now, where before I had a buffer that really had very limited attributes. It really was just the length and the area, right? Now I have all these counties. So I have 6 different entities, one for each county, and then it has all the attributes of the county sort of merged to it. So like I said, this is one of the powerful things about GIS, is because these two things were located in the same spatial location, it could take on the attributes of the layer below it. Okay, so if we wanted information about this, I could, since I have a single entity for each county, I could go and use my measure tool. We did this back in the very first lab. I could measure sort of distances, areas, but this plus one is I can measure a feature. Before I do that, I want to check my units though. So I want to make sure I'm defaulting to acres. So it will tell me as I select each entity how much of that buffer area in acres is in each county. So if I click on this, it's going to tell me which features I have. I'm going to go ahead and turn off some of my other ones so I know that I'm selecting. I'm going to turn off everything but my buffer, and so it's going to tell me how much is in each area. I had that tiny little bit that was in Ferry County, right? And so I can find each one of these 5 entities, right? And it's going to tell me how many acres are in that, of buffer, are in that county. So that's kind of the end of the lab. So what you're going to be doing for your assignment, I'm not going to go through a lot of the mapping stuff because we've been doing that in other labs. So how would I create a nice map that displayed all this information? So this example, we were really focusing on just these two subbasins up here in zoom out, up in the northeastern part of the state. If I brought back and thought about all of my watersheds again, you're actually going to find that you have kind of two main large basins. A significant portion of the state is a tributary or watershed area that goes eventually into the Columbia River through various tributaries. And then over here, kind of in the northwestern part of the state, you have a lot of streams and watersheds that drain into saltwater bodies, whether it's the ocean itself, the Willapa Bay, or the Strait of Juan de Fuca, or the Puget Sound, all of that. And so what you're sort of tasked to do is to go back to this major watershed and go ahead and dissolve them into two watersheds, one that drains to saltwater and one that drains to the Columbia. You're going to also work with the streams again, but this time you're going to limit it to stream orders greater than 8, so only the 9s and 10s, and you're going to create a pretty large buffer, so 10 mile buffer around those large stream orders, large rivers, and then calculate the number of acres of that 10-mile buffer for those two watersheds. So using the same tools that we just did, you're just going to focus on the statewide. You're going to create a map that displays the results. You can either create a table, you can use a label, you can add text to your map, whatever it is, to show how many sort of acres in each of those watersheds are within 10 miles of a stream order 9 or 10. And you'll create that map and either export it or print to PDF or JPEG and then upload that into Blackboard. So good luck. So this will be the last formal lab, and so you'll be getting some instructions in class about how to do your project. And so as we move from doing labs to your project, there won't be any more videos on GIS, and you'll be using tools that you would have learned throughout the previous labs. And in some cases, you'll be given some hints on maybe tools you haven't seen before. But the hope is that through these first 4 labs that you've kind of gotten used to using GIS and are comfortable enough to kind of apply it in a different situation. So good luck. Thanks.